please do fill in the feedback form this time as well. It'll help us organize future webinars and their format based around your preferences. I think we can start. I'll start by welcoming our speaker and participants for the second webinar in the sixth masterclass series on emerging technologies and geopolitical trends, organized by the Ananta Aspen Center. The speaker for today is Dr. Chaitanya Giri, who is a fellow at ORF Center for Security, Strategy and Technology. Dr. Giri's research focuses on both the strategic and scientific domains in space, including India's space ecosystem and its linkages with the global space economy. He also brings a wide range of expertise and experience from his academic background in astrochemistry and planetary science to his role as a board member of India's Satcom Industry Association, as well as his previous work with eminent government institutions like the National Security Council Secretariat, India's space sector regulatory body InSpace, Niti Aayog, among others. Today, he will be speaking on the role of space technology in non-proliferation and verification of nuclear weapons. This masterclass series is made possible by the support of Triveni Turbine Limited. So some housekeeping rules before we start the session. Please add your questions in the Q&A window as the session progresses. We'll be raising them to Dr. Giri during the Q&A session towards the end. And with that, let me hand over the session to you, Dr. Giri.
Thank you so much, Aditya, for inviting me to give this masterclass of yours. I've been keeping a track of all your previous masterclasses, and I'm deeply honored that you considered me worthy of coming and delivering this one on space, use of space technology for nuclear non-proliferation and monitoring activities. The topic is quite intriguing even to me. Although it appears cutting edge, although it appears state of the art, there are so many loopholes within it. There are so many gaps within it. And if you look at the recent history of the modern world in the past, let's say around 30, 35 years, there have been several instances when this particular aspect that you've chosen me to speak on has become both a boon for expeditionary forces and also a bane for them. So I'll touch upon these some of these facets of the past and what lies ahead when it comes to this particular tech, especially now that the times are so precarious. You have several geopolitical hotspots, burning red. On the Russia-Ukraine front, on the Lebanon-Israel front, on the Israel-Iran front, North Korea front. So it becomes very important for us to look at all possible solutions at hand, solutions that can ensure that the nuclear football is not kicked. So thank you so much. I'll be happy to discuss this topic today. And greetings to all the attendees who have joined on this very hazy but beautiful Sunday morning, wherever you are in India. I hope it's not sweltering, it's not hot anywhere. And I'm glad that you could make time out of your busy Sundays, whatever you do. So I'll begin my talk. I'll start sharing my slides now. Put up share. That's my share option. Let me know if it's visible.
Yes, it is.
It is? Okay, thank you so much, Aditya. So straight away, we'll dive into what's happening in the past few days. So it's a matter of days, not even weeks or months. So just a few days ago, just last week, there was a news piece that broke out that the Russians have launched a ICBM, an intercontinental ballistic missile, onto Ukraine. Now, this particular news really sent tremors in all the geopolitical circles, and analysts who have been watching that particular conflict for a long time, they knew that something is amiss. Something is wrong when the news reporters are saying it's ICBM. You can call it as a faux pas, you can call it as a fog of war, you can call it misinformation, disinformation, or purely narrative warfare. What it happened to be was not an ICBM, but a intermediate range ballistic missile, or a IRBM. Now, the Russians launched it. The IRBM was supposed to hit Dnipro. It hit Dnipro on the morning of 21st of November. And within a few hours, it was pretty clear that it wasn't an ICBM, but an IRBM. Yes, indeed, it didn't make any sense for Russia to launch an ICBM onto a country with which it is at war, onto a country which is next door, where it shares its borders, and a country which is not too big. I mean, it's within the ranges of most of Russian IRBMs that are located not only immediately at the border of Ukraine, but also at the border, maybe 200 kilometers into the interiors away from the Ukrainian front. So it didn't make any sense. Why did it say ICBM? Why did the news pick up and say ICBM and not IRBM? Later on, it was confirmed that it was one of the newest IRBMs that the Russians have developed, which is known as Oreshnik. Now, here we start entering the rabbit hole. Now, what's the rabbit hole? A few days prior to that, it was pretty clear, just 2 days before that, the Ukrainians had launched the ATACMS missile, which was given to the Ukrainians by the Americans. And this was one of the first ever NATO missile to be launched from Ukrainian soil onto Russia. The missile traveled some distance, approximately 115 kilometers from the recognized front, the recognized border, and it targeted a very specialized Russian armed force facility of the Missile and Artillery Directorate. The war did not remain onto the Russian frontiers. It entered well within the Russian territory, 115 kilometers, through a projectile of non-Ukrainian heritage, but a NATO heritage. And this is where all hell broke loose, that, okay, NATO is now at the border of Russia, and there is a serious conflict now brewing, not just between Russia and Ukraine, but now directly between NATO and Russians. So it was in the works, it was in the making for a long time, because this particular missile, the ATACMS, was received last year in October, and the Ukrainians waited good 1 year for this particular, for use of this missile. Another interesting part is that this missile was not used at all during the presidential elections in the US, but whosoever was operating it, we believe it was the Ukrainian armed forces, used the missile after the US elections, after the results of the US elections. So, it sort of showed that it is not only a military attack, but it was also a political attack. Another major issue that ran up, which was quite unprecedented, was when the Iranians launched a BV of several missiles, ballistic missiles. It was kind of a saturation attack from Iran into Israel. That happened on October 1st. And that was also a time when the Israelis realized that the Iranians may not have the necessary, technological wherewithal to carry out very sophisticated kinetic and non-kinetic attacks, but the Iranians do have the ability to saturate the Israeli air defense networks, the air defense systems. Now, in both the cases, the ATACMS as well as the Iranian missiles, both of them can carry a payload of up to 560 or almost 600 kilograms of warhead. Now, that 600 kilograms of warhead could be a conventional weapon, and it could also be a a tactical nuclear weapon. And in this case, the entire show, the entire conflict becomes serious. It goes one level up, that whether these two brewing ongoing conflicts, whether will they result into a nuclear attack of some sort. Although there is no reason for us to imagine a full-blown nuclear attack, a multi-million ton equivalent of TNT attack on any city. But the real threat today at this point in time is, can tactical nukes be used on these brewing war fronts? And not only here, the threat also lies on the North Korean, South Korean frontier. It also is possible that such tactical nuclear weapons, if they get proliferated, they can be also shared with state and non-state actors. So the issue is quite serious, and it's very important for the world community to have measures in place where you can monitor the proliferation of, if there is any proliferation happening, very seriously with all measures at hand. And one such measure is the use of space technology, on which today's lecture is based. Then following the ATACMS attack, again followed by the Russian IRBM, there was a revision in the Russian nuclear doctrine just a few days ago. And these were the sort of changes that were made in the doctrine, where the Russians said that, look, we are going to use nuclear weapons if any of these scenarios happen. So the first scenario that the Russians are talking about is if they receive any reliable data about a conventional ballistic missile attack, then against the Russian territory or any of its allies' territory. And in case of allies, what we mean is it could be Belarus, or it could be any other ally in the Caspian region. So if there is any reliable data coming in, the Russians will have a preemptive attack with a nuclear device. The second scenario that they talk about is the use of nuclear or other weapons of mass destruction against Russia or its allies. So that's pretty evident. That's pretty obvious that they would retaliate with equal or overwhelming force. The third scenario is that if they find any adversary action on Russian government or military targets that could affect Russian defense, then Moscow will retaliate with nuclear weapons. So if they find any of the ATACMS missiles coming and hitting the artillery directorate installations, then the Russians, as per this new revised doctrine, will be compelled to use a nuclear weapon. So what they're trying to do, they're trying to ward off any other missile attack from the Ukrainian soil onto Russia, as has happened a few days ago. So all these scenarios are quite tactical. They have experienced it in the recent past, and the Russians do not want any of these attacks to be repeated. And for the very reason, you see the revision. Number 4 is a conventional aggression against Russia or Belarus that poses a critical threat to their sovereignty will also result into a Russian nuclear retaliation. So which means if there is any front that is being opened up from the Belarusian western frontiers or from the Belarusian southern frontiers, which a border which they share with Ukraine, then that will be met with a nuclear attack. And the final scenario is a receipt of reliable data about mass start of aerospace attacks and their crossing of Russia's state borders. So just the way the Iranians attacked the Israelis with an overwhelming saturation, if there is any saturation missile attack coming in from Ukraine or any other NATO country, then if they receive any reliable data, then that will be countered with nuclear attack. So all these scenarios, whatever they have mentioned in the new revised doctrine, is based on the recent experiences of the Russians, as well as whatever is happening, whatever is transpiring all across the world. Now, a very pedantic, a very scholarly academic number is that whenever we talk about nuclear proliferation, the narrative is such that we start talking about the total number of warheads. Uh, which country has how many warheads? And then there is always this approximation that so and so country has so and so many warheads. Uh, Especially with the Russians and the Americans, it was the START Treaty which led to substantial declination, reduction in the number of their respective warheads. But in the recent past, since especially after the Ukrainian conflict, there has been no commitment from either side. First, the Russians decided not to revise, not to extend the current validity of the START agreement. And the Americans, although they haven't said anything like that, but they have taken measures enough to ward off any complication that arises by not revising the START treaty. So these are the number of estimates. The numbers are humongous, but it is not the stockpile which is the threat. As I said, it is the threat majorly lies from adding newer countries onto this list, and the nuclear proliferation which happens through state and non-state actors. If it goes unmitigated, if it goes unattended, then that is where the major risk lies. Now, if you look at global monitoring systems, yes, there are major systems that are in place. These systems are operated by international multilateral organizations. And one such organization, the Comprehensive Test Ban Treaty Organization, the CTBTO, has laid a tremendous network of various kind of sensors all across the world. And to my Indian audience here, we are a country which haven't signed on to the CTBTO. We haven't done that, although many countries have sort of forced us to sign onto it. But what we've said is that, look, our non-proliferation record is quite intact. We are open to any regulations, any oversight by the International Atomic Energy Agency, which looks after the civilian assets. But we are not going to be party to the CTBTO because, as they say in the Indian nuclear policy academic circles, uh, you know, we perhaps as a country are waiting for another test because the 1998 nuclear test, as is said by various insiders, was not of substantial explosive tonnage. So we are waiting for a bigger test to happen. I'm not saying that it will happen anytime soon, it will happen in distant future, but we've kept that option open for ourselves. But we've given a caveat, we have set a precondition on ourselves that we will ensure no first use policy. Now that no first use policy has been in place since 1998. There were regular talks about whether India is going to give away that policy, but that hasn't happened yet, despite several provocations coming in from Pakistani side, several provocations coming in from the Chinese side. But we've stuck to our guns, and we've kept the conflict within the subcontinent below the nuclear threshold. So what you see on this particular map is a swathe of monitoring stations that the CTBTO has laid. These monitoring stations look at different kinds of nuclear testing signatures. So it could be a seismic array, which is looking at any anthropogenic quake, earthquake that is happening because of nuclear test. It is looking at uh, leakage of any radionuclides into the atmosphere because of a nuclear test. It is looking at noble gases which are emitted after a nuclear emission. It could be a leakage coming out of nuclear plant. It could be noble gases uh, coming out of a test or a use of weapon. And many a times, noble gases also come out of volcanoes. So this particular organization is looking at all kinds of geophysical or atmospheric signatures possible, along with hydroacoustic signatures if there are any attempts to carry out nuclear tests deep within the oceans. So again, there are arrays of sensors that are laid within the oceans on very strategically placed islands, which sort of measure the hydroacoustics in the oceans to see whether there are any anthropogenic signatures. So plenty of sensors around, but if you see on the map, there is no sensor within the Indian territory. There is a sensor in Nepal, there is a sensor in Bangladesh, there is a sensor in Sri Lanka, there is a sensor in Pakistan, but none in India. Although the Indian neighborhood is so geographically proximate to each other that any of these sensors, so there are three sensors onto the eastern frontier of India. These are uh, seismic monitoring stations, and the one that is in Pakistan is an infrasound station. So if tomorrow, if India decides to carry out any test, the CTBTO will use these assets in the Indian neighborhood to check whether we've tested. And when it comes to testing in Pakistan, they can easily do that through the CTBTO installations. Uh, there was a period in the past, maybe around 1960s, 70s, 80s, when things were going really berserk when it comes to the estimated number of nuclear warheads. The inventory was humongous, and it helped no country. Rather, if you see this graph, the numbers have steadily reduced further and further over the past few decades. And today, global nuclear warhead inventory is not a concern as it was in the past. And there is a lot of academic literature written by think tanks, written by universities on how to curtail this particular mayhem, this particular mess of too many warheads. But today, the threat scenario is completely different. The threat scenario lies within the threshold of nearly 10 to 12,000 nuclear warheads all across the world. But the seriousness of the threat has not reduced at all. So, although the number of nuclear warheads have reduced considerably, but that has not led to any reduction of concerns. The concerns still prevail, and the biggest concern of all is proliferation. So, how do we exactly use space technology for detecting nuclear proliferation? What is exactly to be done? The first thing that we are going to look at is, can we use space tech to detect, to monitor any strategic nuclear weapon? A nuclear weapon that is placed on a IRBM, a nuclear weapon that is placed on a ICBM. These IRBMs and ICBMs, are they stored in land-based silos, or are they stored in on a SSBN, which is floating uh, without any monitoring in deep into the oceans, whether they're submarine launched nuclear weapon tipped missiles. So there is a separate strategy for that kind of detection. Then another messy creature that has come up, and although it was a American Russian origin design, but in the recent past, especially after the 2008 attacks on Mumbai, the 26/11 attacks in Mumbai, we'll be having that unfortunate anniversary coming up very soon. When India started something known as the cold start doctrine, where it started testing mass movement of our forces onto the Pakistani frontiers, the Pakistanis got rattled because, in conventional terms, the Pakistanis will be defeated by all margins, hook, line, and sinker before a formidable Indian conventional force. But to counter that formidable elephant march of Indian forces towards Pakistan, what they did was they came up with the concept of use of tactical nuclear weapons. Now that is quite sinister, where India is in a position or was trying to keep the conflict below the nuclear threshold. Here we had Pakistanis uh, sort of determined to use tactical nuclear weapons, which are dirty bombs. The yield is low, below 100 kilotons, but it will cause a very hyper localized damage. Yet, the problem is that when you use a nuclear weapon, you've already created a dent in the opponent's heart. So that is where uh, the entire concept of notion of tactical nuclear weapon being used in the neighborhood increased. So the chances of a full-blown strategic nuclear weapons exchange are low, but the possibility of a tactical nuclear weapon is very high. Another thing that you can detect is whether there is any exchange of fissile nuclear material or the entire payload, whether it is being transported both in the white market as well as in the black or gray market, and whether there are any technologies or space technology that can be used to prevent that kind of trade between state as well as non-state actors. Um, it needs a certain level of creativity when it comes to use of space tech, and that is something which is going on right now. So people are becoming very creative. All the atomic energy regulation agencies, national and international, are using that. And so that's the exchange, that is the trade. And whether can you detect movement of fissile nuclear materials, especially while they are being transported. Why am I saying that? Because um, if you hear out experts on Pakistan, experts on Pakistan's nuclear weaponry, the Pakistanis have for a long time been saying that there is no chance that any country would be able to detect, identify, and earmark all of its nuclear warheads. So they've been very confidently saying that, look, we understand that you may be able to monitor around 60%, 70% of our weapons, nuclear weapons, but you won't be able to find 30% of them. Now, where have they hidden these weapons? Have they hidden them somewhere deep into the earth or deep into the oceans? Have they shared this weaponry with some third country, which we can't think of right now? Or have they kept all these 30% weapons mobile? Are they currently being transported from one place to another within Pakistan's? Are they road mobile? Are they being transported on a seemingly innocuous, innocent truck, which you and I perhaps see as a truck which is carrying some food grains, truck which is carrying some cattle or milk or anything like that? And whether in the guise of such a civilian truck, are they transporting a nuclear weapon from one place to the other? So if that is the case, is it possible for us, or is it possible for any country, including the proliferation monitoring agencies, to keep a check on such transported nuclear weapons? That's another challenge for space tech. Beyond beyond nuclear weapons, there are quite a few areas, especially in the civilian nuclear side, where space imagery, remote sensing images, have been used to determine certain facets of a nuclear power plant or a nuclear power installation. Now, these satellites use all kinds of images, they use all kinds of sensors, all kinds of cameras. And one such sensor is the very simple, very crystal clear optical imaging sensor, an optical camera, a high resolution optical camera. Now, this is a study which was done by Giavei et al. Just last year. It came out in a very respected journal known as the Remote Sensing of Environment. And what they were monitoring based on commercial images is very simple thing. They were just monitoring the seashores, the lake shores of some of the prominent nuclear installations, and whether there is any drainage coming out of the nuclear installations into the water body. So it's not that this was a adversarial motivated study. The Chinese studied their own two nuclear power plants, the Qinshan 2 and the Lingao in Daya. They saw that, yes, there is some drainage coming out of the nuclear power plant. They estimated the extent of drainage. They estimated the distance of the plume of drainage coming out in the water body. They studied it for Kudankulam. They studied it for Calivert Cliffs, Sizewell, Dingeness, uh, and they did identify plumes of various kinds, of various sizes, of various coloration. Now, it is very difficult to attribute this particular effluent as a nuclear contaminated effluent because it's not the case everywhere. All these nuclear power plants are very well monitored by the International Atomic Energy Agency. The safeguards are in place. The IAEA inspectors regularly visit these plants. And on top of that, all these countries have a very responsible civilian nuclear program. But what I'm trying to show here is the creativity of the authors. The authors decided to even look at those aspects which are not related to contamination. And what I'm trying to show that there are n number of possibilities of monitoring any nuclear installation, be it civilian or military, if you have the creativity to monitor all kinds of activities happening in and around it. So that's the only, that's one of the use cases that I'm trying to suggest to you all. Then, of course, there is immense concern about the nuclear installations in North Korea. This is the Yongbyon Nuclear Research Center. And again, imagery which is commercial, these satellite images are commercially available. There are certain research institutions and research companies and think tanks which do a lot of technical intelligence gathering. And these two images have been collected from a civilian satellite known as Landsat 7. And the imagery gathered from Landsat has been thermally processed into thermal infrared images to identify what are the surface temperatures of the locality in which the nuclear research center is located. So since this nuclear site is of concern, there is always somebody watching over it, either from the West or anywhere in the world. So it's always being watched. So on 8th of January 2021, when a satellite image of this particular installation was taken up, what you see is this particular temperature profile. So where you have the nuclear site, which is covered in the dotted square, the dotted rectangle, you see the temperatures are slightly warmer on a yellow or a orange tinge. The hills are slightly warmer. No, sorry, the valleys are slightly warmer. The hills are slightly greener on the cooler side. But if you look at the image, which is taken a few weeks later, the nuclear site showed a tremendous increase in the thermal patterns. So it was glowing hot red on the color scale, and there was significant activity detected. So there was activity detected in the radiochemistry lab. There was activity detected in the centrifuge plant and on the thermal plant. So that means uh, there is ramp up of nuclear processing happening. And this ramp up, this sudden change in activities, which may not be visible to a human eye in the optical wavelengths, can be easily made visible in the shortwave infrared or infrared imagery wavelengths. So thermal imagery or infrared imagery is again a very good means of detecting the intensity of activity, production or research activity, or weapon, refinement activity, uranium refinement activity happening on any of these plants. Then again, coming to North Korea, these are images of the mountain under which the North Koreans have been testing their nuclear weapons. This is Mount Mantap in Punggye-ri, and this mountain has been again watched for a very long time. And just a few years ago, around 2019, 2020, when the tests were done by the North Koreans, they found out a substantial rattling when it comes to seismic monitoring systems. So the seismic monitoring systems in China, in South Korea showed a tremendous spike, and it was not related to a geophysical earthquake, a natural earthquake, but something that was man-made. And later on, when cross verification was being done, satellite images showed a substantial change in the topography just above the test site, and the topography had changed drastically, which again is a verification that a certain underground test has happened, however deep it may be, but we are now able to detect such changes very easily. Uh, and You can use optical images, you can use synthetic aperture radar, another technology which can see through a few meters of land to see whether there is any perturbation, whether there are any changes in the underneath geological structure. So again, this is a follow-up study of the images that you saw in the previous slide. So what they suggest was that there were quite a few events that happened, quite a few nuclear tests that happened, that led to a large blast, and that large blast sort of perturbed the mountaintop in a way that there was a lot of subsistence from the mountaintop. A lot of land was displaced, and this displaced land was measured, and based on that measurement, they also tried to deduce the intensity of the nuclear test. So these are all techniques that support each other when it comes to understanding various facets about a nuclear test, about a nuclear event, about a nuclear activity, and so on and so forth. So when I say that these are tests, or these are sort of mechanisms which support each other, what I mean to show to you is the various kinds of intelligence gathering sources that are possible. Now, one way to look at any nuclear activity. So when you asked me to prepare for today, what I did was I took some bits from my own human intelligence, which is human, things that I hear, things that I see, things that I experience professionally, that is human for me. When I derive something that is entirely from the internet, that it becomes open source for me. If I'm looking at any signatures that are giving me a chemical analysis or a geophysical, geological analysis, I could be using water bodies around the nuclear site to see whether there is any spillage, any radiation leak. What I am doing is MASINT, which is measurement and signatures intelligence. Uh, if I am looking at a flash, let's say in a scenario that there was a satellite, in a scenario, it's a hypothetical scenario, that there was a satellite operating during the Hiroshima Nagasaki times. So what would have happened? That satellite would have definitely picked up signals from Hiroshima and Nagasaki, the flashes that came out, and it would have immediately informed both the parties, the Allied and the Axis forces, that okay, there is a flash, and here's a confirmation that a nuclear test or a nuclear weapon has been used. So that's SIGINT, where you use signatures of of a kind which does not entail chemical or biological analysis. That is SIGINT. And then there is IMINT, which is imagery intelligence, which we've been talking about today in the past few slides. So when it comes to nuclear non-proliferation, when it comes to ensuring complete monitoring, end-to-end monitoring, it is a play of all these kinds of intelligence gathering meshed with each other. There is no way to say or attribute or to assertively, sort of say that this is the best technique. No, there's no one best technique. You have to use all of them to a varying degree. So what kind of new geospatial tools are being used right now? At this point in time, say since the past 10, 12 years, when we all started to use Google Earth immensely, uh, commercial satellite images have been used uh, in a great volumes, in great quantities from satellites coming from all quarters and all countries. Then Wikimapia is another layer that have been used early in the 2010s, but not anymore. There's a lot of chatter that happens on social networks, on social media. That chatter also is very important to intelligence gathering communities. Then experts like those at Ananta Espen Center or at ORF, we keep on analyzing certain situations. We keep constructing scenarios, and that also helps a lot. Then there are NGO databases. So you have NGOs like the ISIS, not the terror firm, but the NGO which deals with nuclear non-proliferation. You have the SIPRI, the Stockholm Institute of Peace Studies, and all of them. You have the uh, Federation of American Scientists, FAS, Bulletin of Atomic Scientists. They all keep a database on stockpiles and all that. Then there is open source services like Jane's, Intelligence Online. They give you information on the kind of nuclear weapon delivery system, the new weapons in the market, the new weapons, strategic weapons that a country is being developing. Then information that is coming from member states, and member states, those who are voluntarily giving that information into the IAEAs, the CTBTO, or the UNOSAT. So this information also factors in. Then there is media reporting that comes from your mainstream media. Uh, so that is also taken into consideration. Although now there is a fight between social media and media, conventional media, the frontline media, which of it is faster, which of it is more accurate, which of it is unbiased. And so all this information plays a great role in the synthesis and analysis of use of geospatial tools in nuclear monitoring. So if I were to understand whether an Iran or a North Korea or a Libya or a Iraq or a country which has not had a nuclear weapon but may be having a nuclear weapon very soon, what kind of activities should I be looking at? So I should be looking at uh, some of the activities that are mentioned in the blue column. Uh, I should be looking at all the uranium mines in that country or wherever they are sourcing the uranium from. Uh, you will be seeing piles of ore, the tailings that are coming out of extraction of these ores, whether there are large trucks, the kind of trucks that are being used to transport uranium from one place to the processing units. So that has very high detection potential. You can easily detect that with any commercial satellite. Uh, will you be able to look at conversion? Will you be able to look at how it is being processed? No, you won't be able to look at because do not have that tech right now. And geospatial is not the right technology to look at that activity. Can you look at what's happening within centrifuges? No, you don't need satellites for that. Gas centrifuge is something that you can do it human. You can use Marsent. You can have maybe drones, small drones coming in, peeping into your nuclear facilities. That is possible. So, but geospatial is not. That's why it's none. Gaseous diffusion, high power demand, high voltage supply lines, cooling towers. Yes, that will also give a heat signature. So, medium detection, uh, uh, so on and so forth. So, there are various kinds of, there are various aspects of a nuclear installation that you could look at through satellites, but it will again have a varying degree of detection potential. So, what are we doing when it comes to satellites? We are picking up images, we are processing those images, and then we are also giving you an analysis out of it. And all this, if it falls in place seamlessly, without any hiccups, with great reviews, with great peer review, you definitely have a successful satellite imagery, uh, a successful satellite non-proliferation. But what does it require? What kind of talent does it require? You'll definitely require somebody who's working in the space industry. So somebody who's working in downstream sectors, satellite imagery sectors. So you'll need somebody like that. Somebody who has an eye to determine what exactly you are looking at. Because an untrained eye won't be able to decipher between what is what. So you will need that. And then you will need a nuclear analyst who will tell you that, okay, this structure looks like this structure looks like this is a centrifuge hall, this is a cooling tower, this is that. So you need talent across the board to come together to synthesize, process, and analyze and make sense out of it, so that there is actionable intelligence for your forces, for your special forces, for your diplomats to take necessary action. So I'm saying both special forces and diplomats in the same team. Huh? But there have been history of false positives. So if you look at the entire narrative that was created in 2003, especially after the US, the NATO invasion of Iraq, there was suspicion that Iraq is having weapons of mass destruction. And later on, okay, there were no signatures, there was no intelligence coming from nuclear detecting systems, and that's why Powell, the then Secretary of the U.S. government, he asserted that yes, there are nuclear. He asserted that there are weapons of mass destruction in Iraq, and you should be invading Iraq just to get rid out of it. What happened later on, just because there was over analysis or there was a false positive, was that the Americans, the NATO forces, never found any chemical weapons or biological weapons in Iraq. Nothing was found, but that resulted into deaths of several lakhs of people, innocents in large numbers. So when I started this talk, I said that there have been instances where this particular topic that we are discussing today has been consequential. Yes, it has been consequential when it came to the invasion of Iraq. And later on, that country was left in tatters for good 2 decades. It is now trying to slowly come out of that, the chaos that was created then and the chaos that followed later on in the form of ISIS. But it was the false positive in the intelligence circles that led to this particular misery in that geography. Similarly, satellite images have to be analyzed very carefully. You have to verify, you have to get it peer reviewed internally. Yes, of course, since you are gathering intelligence for your own country, you can't have an international peer review for it. But you should have at least several sets of trained eyes, trained imagery analysts, trained nuclear analysts to ensure that what they are seeing is what exactly they are seeing. Because I'm showing just two images to the left of this slide. Uh, there is a facility which is known as the IR-40 radioisotope production reactor. This is in Arak, in Iran. This is how it looks uh, from the skies, from the satellite on 4th July 2014. And this is how it looks on ground, just below it. And there have been instances where the Burj Fars International Hotel in Shiraz, it was a hotel, it was a nice five-star hotel, which was being constructed, but the structure was laid out, the DP, the detailed plan of that particular hotel was laid out in such a manner that there were analysts who believed it to be a nuclear site. It ended up being a hotel. So over analysis uh, takes away a lot of unwanted attention. It takes away a lot of precious attention of yours, leading into nothing. An intelligence agency is also short of good talent, and you don't want to invest your talent in observing targets which are not of military concern. So this is what happened. This is one of the lessons learned, that over-analysis, false positive leads to intelligence failure. And if a country, or if a military, if a force, if a brigade, if a command is acting on intelligence which is not foolproof, then it leads to disastrous situations and even collateral damages in the form of civilian deaths, which should be completely avoided. What's happening next? Space technology is not just about imagery. It has been so for a very long time, but today we are developing as a world uh, technologies like the hypersonic and ballistic tracking and surveillance system, HBTSS. This is being built by Lockheed Martin, where a constellation of satellites in the low Earth orbit is being laid in such a way that these satellites are perhaps able to track hypersonic weapons that are in boost phase, that go high up the altitude, get into the re-entry phase, get into the pull up and glide and maneuver phase, and then intercept. Although it's a holy grail of physics, there is no technology at this point in time which can detect hypersonic weapons. But Lockheed Martin is trying to do that for the Americans, just because they are wary of the Russian and Chinese hypersonic weapons, and perhaps even Indian hypersonic weapons. So, ensuring that these hypersonic weapons can be monitored will lead to also keep in check uh, a nuclear attack happening via a payload on a hypersonic weapon. So that's the holy grail of physics that is currently being worked at. And in the next few years, this is my last slide. In the next few years, what you will see that Indian space startups have grown big. Many of the Indian space startups are imagery intelligence startups. We, as Indian think tanks or Indian strategic analysis community, should be encouraging these space startups to provide us with images so that we help in appropriate analysis, true positive analysis of certain installations that are of concern to India, and ensure that these commercial images that are readily available to us at very cost effective subscription rates, cost effective not for individuals but for your institutions. So as an institution you can definitely um, subscribe to imagery supplies that they are offering to you as customers, and use them to make sense out of it. Because this is the last slide again. Middlebury Institute of International Studies at Monterey, a think tank, an academic institution. Look how beautifully they've been using images coming from Planet. Planet is a low Earth orbit satellite commercial imagery company, and they've been using it to monitor activities uh, at nuclear sites of concern in Iran. So exactly the same way, we could also do that as think tank analysts. And more think tank analysts will have to learn some or the other technical skills. This is what I believe in. So all the youngsters, you out there, think tanking is not just about writing op-eds or writing a lot of prose. Think tanking is also about having certain skill sets, technical skill sets. It could be a programming language. It could be some kind of technical analysis prowess. Please gather them and ensure that you are well equipped, because just writing prose uh, does not help. You have to substantiate your theory, your thesis with data sets, with tables, with infographics, with maps, with a lot of techniques. And all those who are interested in monitoring nuclear sites of concerns or monitoring nuclear activities of certain state and non-state actors, you'll have to learn these techniques, put them out together, and be the best in whatever you're doing. So with that, I conclude my talk, and I'm happy to receive questions from you all.
Thank you, Chaitanya. So there are already two questions in the chat. I'll read them out to you. How will space technology affect a possible nuclear use verification scenario in the Russia-Ukraine war, especially if it's a very low-yield warhead detonation, maybe even a suitcase dirty bomb? Will space technology be one of the tools used for verification by the international community?
So, yes, one way of determining whether there is a major flash uh, that is created because of a nuclear weapon is to use imagery intelligence, because a flash that appears out of a conventional weapon, including the big fat bombs uh, or the Moabs, is very different. So the flash that comes out of after the blast is very different. A nuclear weapon, be it small enough, even if it is coming from a dirty bomb, it will have a double flash. So that double flash is actually a signature if you are able to capture an image in real time. So your satellite needs to be in the orbit at that particular position to catch that image, because it's all happening within seconds. So one big challenge that is coming up is that most of the nuclear monitoring satellites, uh, and they've been around for quite some time. It's not a new tech. It's been around since the 1970s. DARPA has built the Vela series of satellites back in the 70s. But uh, you'll need a constellation of satellites. And we are not very sure uh, how many satellites do we need in that constellation to ensure complete sanity and sanitation when it comes to a nuclear test or a nuclear attack. So we don't know that. So that's why you do have a tech, but that tech may not work if it is not at the right place at the right time. So that would be needed. It's possible if it's around.
All right. So the next question is, we've seen the entry of privately sourced satellite imagery in the conventional warfare discourse. But have there been instances where test launches of a nuclear capable missile is confirmed by imagery provided by a private company?
No, I don't see any open source example out of it. But most of the imagery gathering companies, commercial companies, have some sort of agreements tied up with their respective militaries. And whether there is any exchange or any agreement to have such kind of disclosure or such kind of an exclusive sharing of data uh, with the strategic forces who are monitoring such nuclear attacks is not in the open source, but one can gauge, one can sort of fathom that there could be mechanisms in place, there could be agreements in place to facilitate that kind of data exchange whenever and wherever it happens. But as I said, you need to have those many assets in outer space, and only then you will be able to detect anything like that. And low Earth orbit has its own issues. Low Earth orbit is good for SATCOM. but low Earth orbit is not good because it does not give you a broad field of view. You have to go further away from Earth to cover a broader field of view of that particular space. So, for instance, if you're trying to monitor entire Russian territory, you can't be a low Earth orbit satellite. You have to go slightly away from it so that you capture all the territory from Kamchatka to Belarus. So you need to go higher in the orbit. And when you go higher in the orbit, what you compromise on is the resolution. The resolution dwindles. So again, that particular permutation combination needs to be worked upon. There are companies that are trying to work on that. Um, they'll have a solution in place, but whether they're takers for the solution, whether they get the right contract at the right time is something to be seen at.
All right. So I think there's another question tied to the private space sector in India. What will be the role of India's private space companies in the future of space-based verification of nuclear weapons? Are there any companies that offer Earth observation services that can also be repurposed by the government to fulfill national security needs?
So as I said, there could be companies who are doing that. We don't know because these things do not come out in the open. So they remain hush hush between that company and the agency or the force involved. So it could be happening. Indian companies must aspire to do that is all that I can say, because with the Indian government giving them the leeway, giving them all the benefits at an equal pedestal to ISRO, they should be doing these kind of activities. And of course, beyond the commercial realms, beyond the civilian realms, a commercial entity has a lot to benefit from by partnering with a defense space command or a defense space agency. So that particular synergy uh, should be doing what the question is asking me to do.
All right. There's another one tied to the private space sector, although not necessarily. How will small or micro satellites affect monitoring efforts for nuclear treaties and organizations that oversee their implementation and enforcement?
Um, I didn't get the connotation of that word affect. If it's a positive connotation or a negative connotation, but
I
I
think, yeah, I think there's no connotation attached to it.
uh, uh, but yes, nuclear treaties. So the IAEA has been using satellites for a very long time. But since it's a legacy issue, they have been collecting all these images from space agencies. So all the governmental space satellites have been providing the images to IAEA or even to CTBTO. Now we are not party to CTBTO, and that's why we don't share these data. But our internal safeguards are quite robust. So you never know. A satellite which is being monitored by the Indian Armed Forces with the strategic space cell that the Indian Armed Forces operates. It could be using that to monitor activities. So we could be looking at nuclear sites that are of concern to us. I can openly say we look at Pakistan very closely. So do the Pakistanis look at us. But yes.
All right. So I think just picking up on that point, do we have any information on how China, Iran, and North Korea use space technologies to further their nuclear use calculations? Should we assume the Chinese are as obsessively counting Western nuclear silos and launchers as the West seems to be counting the Chinese ones?
Very good question. They certainly are. The problem lies with us, and the problem is that we don't look at Chinese literature as much. And the Chinese being a close society, they may not be chattering a lot about in their think tank circles or in their talk shops, but the way the Americans do or the Westerners do. And since we understand the language, we consume that information pretty, in high volumes than what we do in the Chinese chattering circles. With the number of satellites that are being launched by the Chinese, they are launching synthetic aperture radar satellites. They are launching electro-optical satellites. They are launching really high resolution, optical infrared SBIR satellites. And all these satellites and the kind of wavelengths that they look at the Earth uh, are very useful in monitoring all kinds of nuclear activities. So, assuming that uh, nuclear activities of concern are only in North Korea, are only in Iran, but not anywhere else in the world, is a bit hypocritical. Everybody is looking at everybody. And all those who are capable of looking at planet Earth at all wavelengths will exploit these kind of applications to the T. So the Chinese are definitely looking.
All right. I think we are out of the questions which are specifically tied to. I think there's one. How think tanks, academia, and Indian space industry helps government or military to develop these new monitoring capabilities to detect, analyze, and defend us.
So, as I said, in the think tank circles, all this while, our predecessors were only talking. They were only theoretically, explaining their stances. The think tank realms in India have changed drastically. There's a lot of technical talent, there's a lot of STEM talent that is creeping in. Uh, of course, there are experts of IR who are joining in large numbers, but it will be really nice to see when a think tanker who's a STEM graduate or STEM trained person who's working with the IR graduate and they're joining forces to come up with some new theories, some new observations, something that is going to help the government. So that kind of synthesis, syncretic synthesis needs to happen. And I'm pretty sure that there's now great interest in geopolitics. The kind of YouTube videos that you see these days. Some are outlandish, of course. Many of them are outlandish, but there's some of these videos, some of these podcasts that are very beautiful. So what I'm seeing is the think tank, academia, and space industry can come together if there is nice synergies between the technical and non-technically trained people.
All right, so we have a few questions which have aspects we should really merge together that fit in very nicely. So, for example, uh, since satellites are very difficult to maintain and oftentimes inaccurate, how would they be used for verifying nuclear weapons by countries which might not have the resources? Let's go with that angle for this one.
That's where the power parity lies. You either have weapons or either you don't. You either have the ability to detect weapons, either you don't. For those who don't have the ability, then you have to rely on international bodies like CTBTO or IAEA. If you have the capabilities, you develop the capabilities, uh, keep the keep the avant-garde of that intelligence to yourself and share some with the CTBT or an IAEA just as a way of communicating to the rest of the members that, look, you have the wherewithal and you've just revealed a 1% or a 5% or a 10% of it as a power projection measure. Uh, there is no substitute to power. All countries, big or small, should aspire to have that power. Countries who do not aspire to have one, or countries who are still far away from getting onto that pedestal, uh, they'll be at mercy of these multilateral bodies. And whosoever is in control of these multilateral bodies will dictate what kind of narrative is to be spread. So for a country which is not capable of developing or observing nuclear weapons, they are at mercy of these multilateral agencies.
All right. I guess we're out of time. So I guess we'll have to bring this to a close. Thank you, Dr. Giri, for this insightful presentation and great discussion. But before we close this session, a gentle reminder to our participants and especially first-time participants that we will be issuing certificates to students who attend 2 or more masterclasses in this series. So please don't forget to fill and submit the feedback form link so that we can issue you your certificate with the correct details. The link to the feedback form will arrive shortly in your inbox. And on that note, thank you, dear participants, for joining, and we look forward to you joining our third masterclass, dates and details for which we will be announcing soon.
Thank you.